Hello guys, how are you? I hope you all are good and healthy, right? So in the previous class we finished off our topic that when should we buy the public good. Okay, so in this class we are going to discuss that of what level or of what quality public good you will going to buy, and we will derive out the condition. So it will be different level of public good. That is, you were going to buy the TV. If I take the same example from the previous case, you were going to buy the TV, but in this case we will see that which TV you are going to buy, whether it is LCD, LED or 4K or 32 inches. So what was the level of the public good now? Okay, so the roommate A and B have decided how much money they will spend on the TV, right? So the more money they decide to spend, they purchase better quality of TV, right? Suppose that X1 and X2 represent their private consumption. It is the same from the previous example only. I am not changing the example so that it will get clarified to you. And G1 and G2 represent their contribution to the purchase of public good, and the cost function of public good is CG, that is CG. This is the cost function for the public good, where G measures the magnitude of public good. Magnitude of public good. Okay, G is here the magnitude of the public good. Okay guys. And what is the constraint with them? The constraint is that the total amount they spend on public and private consumption must be equal to their total wealth. This is basically the constraint. So if you can write down here, it will be x1 plus x2 plus the magnitude. See, that is, this is the basically the cost incurred on purchasing the TV, or G, where G is the magnitude that of which magnitude, that whether you are going to buy 32 inches or 40 inches or 56 inches. Okay, G is the magnitude. It should be equal to their summation of wealth. So now we all know that the Pareto efficient allocation is that allocation where a person is well off as possible given the utility of another person. Okay, therefore we can write this problem as maximize the utility of one person such that utility of second remains constant. So what you are going to do now, that you will take the utility of one consumer as a constant and maximize the utility of other, keeping the other consumers utility as constant. So it will be, if you write it down as a max function, it will be, you have that I'm taking that I'm maximizing the utility of first consumer. So it will be this. And what is the constraint? There are two constraints with us. First of all, that utility of 2, which we are taking constant, it is also the constraint. And what is the second constraint? Second constraint is this only, right? X1 plus X2 CG W1 plus W2. So now you have studied Lagrangian only for the two variable, but here if I apply the Lagrangian, it will be more than two variable, and you are not taught that. Okay, and also it is not given in your reading. They have just directly written this, and they have written the Lagrangian function, which is u1 g comma x1, that is this only, same thing, and it will be lambda 1. You are only known till the one constraint only. Okay, but here it will be two lambdas, but you have only studied for the single lambda, that is single constraint, and there will be lambda 2, that is x1 plus x2 plus cg minus w1 minus w2. Okay, so there are two constraints here. And what if you solve this, there is a particular method also, but I won't go into this since your author doesn't want you to solve such, he has also given the direct answer. So after solving this, you get the optimality condition, which will come out to be MRS of 1 in modulus plus MRS of 2 should be equal to MC of G, marginal cost of G. Or if I want to rewrite this, what you can write MRS. MRS is marginal utility of good 1 upon marginal utility of good 2. So this is this. Similarly, you can write this also as this, and it is equal to MC of G. Okay. So this is your optimality condition which came. So now if I want to show this in a diagram, then that what happens if we don't follow this condition, what will happen then? So this is your graph, this is your MC and MRS, here it is your public good. So as you can see, there will be two DD curves, with one with MRS1, this is for MRS1, and this will be for MRS2. Okay, and if you find out the market demand function for public good, it will come out to as this. Okay, and let us suppose that MC is upward sloping. This is the MC of G. So now if you see, according to the condition, this is the point where the DD function, that is MRS1 plus MRS2 is equal to MCG, because what is this curve? This curve is nothing but summation of the other two curves. So this curve is MRS1 plus MRS2 curve, and this is the point where the optimality condition is satisfied. So this will be your G star. So let us suppose that here comes our, if this condition is not fulfilled, and let's say it is that point on this curve, that why at this point there is no optimality, we will see that. Then why it won't be Pareto efficient. Okay, this is the condition of Pareto efficiency, but if we move on other than this point, there will be Pareto inefficiency, and we'll see how the market will work and how he will reallocate his spending on the public good. So this is the case where your MRS is greater than MC, because you see at this point MC is this and MRS this. So at this point, you know, there is no optimality. So what will you do? You will start spending more on the public good. Okay, because efficiency requires that in spending on public good should increase. Similarly, if you take this point G1, at this point what is the case? MRS plus MRS1 plus MRS2 is less than this MCG. So at this point, then efficiency requires spending on public good should be reduced. Okay, so you will come at this point only, G star, and it will be the only point of your Pareto efficiency. As in all case, there will be one small case of this also, which we are discussing in every single case, that is of quasi-linear function. Then what happens if this is a quasi-linear function? So in general, you know that optimal amount of public good will be different at different allocation of private good. But if consumer have quasi-linear preferences, then there will be a unique amount of public good supplied at every efficient allocation. So if you want to express the utility function, you can express it as u1 in bracket x1 comma g. Same function we used to take earlier, right? u2 x2 g is equal to x1 plus v2 G. Okay, and also if you find out the MRS of this function u1, I'm just calculating MRS for 1. So what will it be? Mux1 upon mug, right? What is mux1? It will be 1 upon, it will be v1g upon delta g. So if you solve this as, it will come as delta g upon v1g. So you know the, similarly you can calculate for this also. Also if you want to see from the optimality condition, you know the optimality condition is this, mrs1 plus mrs2 is equal to mc of g, right? Now you will substitute the value of mrs. What is your mrs1? mrs1 came out to be delta v, sorry, what is your mrs1? So it will be your this delta g upon delta v1 upon g. Just to make it simple, we have just interchanged the code that u1 is equal to g upon x1. So mrs x1 will be mug upon mu x1. So what will be your answer? Your answer will be this only. It will be delta 1g upon delta x. You can do from this also. This is also same thing, but in your book it is done like this, so I am showing you this. Delta g is equal to mc. Okay. Now this only shows that the equilibrium that determines the public good is now only dependent on G only. It is not at all dependent on their private consumption, that was x1 and x2. As you can see, there is no role of mu x1 here because it is 1 only. Okay. Because there is a efficient level for the provision of public good. Okay guys, so this was all for today's class, and in the next class we will finish off our next topic, that is free rider problem, and it is important also from examination point of view. So this is all for today's class. Thank you for watching guys. Bye bye, take care. Okay guys.